Okay, next question is should be fairly straightforward. So what you're trying to do here is you're trying to find z minus iota. Z is already given. Just keep in mind that whenever you are adding and subtracting complex numbers, the preferable form is always the Cartesian form, and whenever you're trying to multiply or divide, then the preferable form is the polar form or cis theta form. So here we are trying to find z minus iota, and we can do that only if we have z in the Cartesian form, and that's what we're going to do as we start this question. G is equal to cis 5 pi over 6, that gives you cos Now I would expect all of you to have the unit circle in your head. So like when I look at 5 pi over 6, I see I see the unit circle in my head, and I see that it is close to the negative real axis, negative x-axis, and the cos 5 pi over 6 will come out as root 3 over 2 plus iota sine 5 pi over 6 is basically 1 upon 2. Okay, and once done that, I can do z minus iota. Z minus iota is z minus iota gives you minus root upon 3 minus half iota, and therefore the imaginary part of z minus iota is minus half. Be careful here not to include an iota in this, because when you talk about imaginary part, it is only the coefficient of iota. That done, let's move to next question. Should be fairly straightforward. So you need to mark z to the power 2 and z to the power 4. Again, you are raising them to a power, basically you are multiplying. So you need it would be preferable to use the polar form. So we need to first convert z into the polar form. So mod z, we can see it is equals to square root of 1 plus 1, which is equal to square root of 2. And when it comes to arg z, we need to always draw the diagram. I strongly recommend that when you're trying to convert a Cartesian complex number into polar one, you should always draw a diagram. So I can see it is in the first quadrant and 1 1, and this angle should be pi over 4. So my arc z is equals to pi over 4, and that gives you z is equals to not mod z, and therefore z is equals to root 2 cis pi over 4. I can mark z here now. Root 2 is basically 1.414, and cis pi over 4, so I go pi over 4 from here. This is 30 degree, that's 60 degree. Pi over 4 will be here, and 1.4 will be here, and that is my point. I'll say that is my point A. So this is point A, that's point B, and point C. Once you got z, now you need to find z square. Z square is root 2 cis pi over 4, and here I will need to use Vacas theorem, which tells me that this is equals to cos 2 times pi over 4, which is equals to 2. Looks like cos, it should be cis, which becomes cis pi over 2, and so pi over 2 is here and 2 units is here, so that's my point B. And to find z to the power 4, I do square of z square, and that gives me 4 cis 2 times pi over 2, which is equals to 4 cis pi. So cis pi is here on the negative real axis, and 4 unit is here, so that is my point C. Simple question, very easy, straightforward. Let's move on to next question here. Okay, so we are given z here and I say that mod z is 1. It's really important. We'll see why this condition is, this restriction is placed here. So it's represented by the point on the following Argand diagram. So this is our z, and we need to find the same diagram. We need to mark and label the complex number 1 upon z bar. So we'll go step by step. Z is here, so where would your z conjugate would be? Z conjugate will be is reflection in a real axis. So my z, this point is my z conjugate. And now when we take axis, okay, whenever we take a reciprocal of a complex number, then what you have, it goes, when we take reciprocal, then what happens is, when we take reciprocal, your mod gets a reciprocal, or we take a mod is how to write it. Say, let's see, when we do these two things, we take 1 upon mod, and then we take for argument we take minus argument. So again, so first thing, let's take mod 1 upon mod. So 1 upon mod will be somewhere, because it's more than 1, so 1 upon mod will be less than 1, so it will be somewhere here. And then we take negative of the arc, so negative arc will still be here on the same line connecting here, but your this 1 upon z bar would be here. That's my 1 upon z bar. Now you can see why this restriction mod z is greater than 1 taken here. If mod z is equals to 1, if mod z equals to 1, then you land back on this point. That's your original point. In fact, if mod z equals to 1, then 1 upon z conjugate is equals to z. You basically land back on that. Or if when mod z is, so you see, when we say here that when mod z is greater than 1, your argument here, this mod will be greater than 1, and when you take reciprocal, the length of the complex number would be less here. So that's how you land here. Okay, next question should be, there is a slight trick in the next question, and we'll need to be careful to keep the domain of the complex number in mind. So first thing we got here, let's because we are trying to find the argument of this z, so we need to convert whole z into the polar form first. So let's work with the numerator and denominator separately first. So 1 minus root 3 iota, so S mod is equals to square root of 1 square plus root 3 square, which is equal to square root of 4, which is equals to 2. And then we need to find its argument. So as always, I recommend that you draw the diagram first, so that you know in what quadrant your complex number is. 1 root minus 3 is here, so this is root 3, that is 1, and I can see that this angle is pi over 3. So arg is equals to minus tan inverse root 3 is equals to minus pi over 3. Therefore the numerator becomes 2 says minus pi over 3. And likewise we work with the denominator here. Denominator is given as minus 1 plus iota, which tells you that its mod is square root of 1 square plus 1 square, which gives you square root of 2. And arg, just seen from the diagram here, minus 1 plus 1 is here, and this angle is pi over 4. So we can see that the arg is pi minus pi over 4, which is equals to 3 pi over 4. And now we can see what z is equals to. So z equals to, where is it? Numerator 2 minus pi over 3 divided by root 2 cis 3 pi over 4, which if you simplify, you get 2 root 2 cis minus pi over 3 minus 3 pi over 4, and you can write that as cis 2 root 2 cis minus 13 pi over 4. So now here, see, many of you would tend to stop the question here stating that that's the arc of this z, but this is not the arc of the z because it lies outside the domain. The domain of z, arc is equals to, basically, if you remember, arc is less than equal to pi and is greater than minus pi, so it has to be within this range, within these two values. But here what we have is a value which is outside this range, so we need to basically convert that into, write that in the form where it is within these two ranges. Now we can do that easily if we draw the diagram as well. So first let's look at where this minus 13 pi over 4 lies, and then so minus 13 pi over 4 is basically, you get 4 pi over 4, 8 pi over 4, you come here 4 pi over 4, then 8 pi over 4, 12 pi over 4, and minus 13 pi, all because you're moving the negative direction, so minus 13 pi over 4 will be here. So you could straight away say that arc of, does it make sense, or let me explain it a bit more in detail. So minus 13 pi over 4, basically it is, if you write minus 13 pi over 4, you can write that as minus 12 pi over 4 minus pi over 4, which basically becomes minus 3 pi minus pi over 4. So you start in the negative direction and go by 3 pi. So 1 pi, 2 pi, 3 pi. And then you go further pi over 4. So you come here. That's where your complex number will be. This z will be. So it's g's argument now. Once we find the location, g's argument is this angle. So we could, looking at this, we can straight away say that z, because this is pi over 4. So this argument is equal to 3 pi over 4. Yeah, we could write that straight away. We need to explain. We probably can explain that drawing a graph, drawing the diagram here. Or other way of doing that is we can just add 4 pi here. So 4 pi minus 13 pi over 4. Just remember that cis theta is equal to cis theta plus 2k pi. So just I have added 4 pi here, and that would not change anything. Okay, when I simplify this, it becomes cis 16 pi minus 13 pi divided by 4, which is root cis 3 pi over 4. Therefore, wrong spelling. Therefore, arc z is equals to 3 pi over 4. And that's your answer, and that's where we are going to stop.